So for this question, we are supposed to find the maximum vertical distance between the line and the curve for x more than equals to -4 and less than equals to 5. So in this domain, right, we want to check out the vertical distance between the two functions. If you were to draw them out, right, you can see that the line will look something like this. And let's say I've just drawn the curve first. Y equals to x squared, as we all know, is our favorite parabola. This is y equals to x squared. The x-axis and the y-axis. Y equals to x plus 20. Probably look something like that. At the point where they actually touch each other, is at the point 5. It's also at the point -4. Okay. So for x is between -4 and 5, you can see that the blue lines above the black line, and we are finding the maximum vertical distance, which is basically, if you want to observe, right, it's as though I'm looking at like this distance, right, between the two y coordinates lah. So how do I measure, like, for example, this dotted yellow line? I want to find out what is the longest possible that this yellow line can take. Okay, so this is the distance between the two y coordinates. So I mean, as you can see, these two y values, right, we are actually looking at this as a function. Let's call it L. And what we are trying to do is we're try to maximize L, or basically the longest that L can ever be. And how do we find this L? Now this L is none other than taking the difference in the two y coordinates, right, of the two functions. So on the blue line, this y here, which is a variable point, right, it would be represented by x plus 20, right? So this would be like for example, my y1, right? This is my y1. Subtracting away y2, and y2 will just be x squared. Okay, so this is our L. Our L here basically is a variable that is the difference between the two functions, the two y values. And the two y values can be written in terms of x. So I have x plus 20, subtract away x squared. Now if I want to find the maximum distance, very simple. All right, we see that this is a differentiation question. We can do dl dx. That gives us 1 and minus 2x. All right. Now to find the stationary point, we equate dl dx to 0. This gives us 1 minus 2x equals to 0, or x equals to half. Okay. Now from here, using the second derivative test, if I just differentiate one more time, d2l dx squared will turn out to be differentiating at this, again, is -2. So you can see that indeed x equals to half, not even substituting, gives you the maximum L possible, right? Maximum value of L. So next, I want to find the maximum distance. So just basically substitute x equals to half in to L, where L is basically x plus 20 minus x squared, the difference between the two functions, right? The difference between y1 and y2, that's the vertical distance. So this basically is half plus 20 minus half square, which gives us the answer to be 81/4. So the answer is just 81/4 units. Thank you.